Okay, guys, sort of unexpected. I forgot to mention this to you yesterday that I was gone. Sorry, I'll be back Monday. So we're going to follow along with this video together to go through the rest of the 4.3 lesson. So as usual, if you didn't watch the Edpuzzle, you're going to be a little bit behind. I'm just going to really quickly, briefly go through the 4.3 vocab, and then we'll go through a couple problems together. After this, if you didn't watch the 4.3 Edpuzzle, you can, and then go into the assignment if you were still a little bit confused. So this is our last special segment called a mid-segment. What this one does is it connects the midpoints on two sides of the triangle. Two things end up being true here, or I guess we could say actually, maybe 3 or 4. All of my sides are cut in half because I'm talking about the midpoint. What ends up happening is this segment here that we call the mid-segment ends up being half the length of the side it's parallel to. So again, that's in your notes. So for example, if this was 10, what would that make this piece if this piece is half as long? 5, right? So that relationship is true. That again, these are also going to be parallel. So this little one here is half as long as the one it's parallel to. And again, we have all of our sides cut in half because we're talking about midpoints on our sides. So that was a very brief overview. We're going to try it real quick. I'm going to warn you guys, stay on your toes here. I'm going to jump around to a lot of different problems. I'm rearranging the order of the problems a lot. So pay attention to what example I'm on. So we're going to jump to example 4. So take a second, get there in your notes. Example 4. We're going to quickly, before we answer these questions, practice that concept we just said. We've got 3 mid-segments drawn here. In that picture, you only saw 1 mid-segment, but we can actually draw 3 mid-segments. Oops, example 4. So this is a mid-segment, this is a mid-segment, and this is a mid-segment. Yeah. Again, these connect the midpoints of each side. So this is the middle of this side, this is the middle of this side, this is the middle of this side. So knowing that, let's go ahead and fill in the information we can figure out before looking at what they're asking us to find. So if this is the middle of this side here, for example, I know that this is 8. Immediately, that tells me what this piece is. What would that be? 8 as well, right? If this is the middle and just up to here is 8, that makes this piece 8 as well. Coming over here then, same thing. If I know this is 10.6 and that this is the exact middle, what does that make HF here as well? 10.6, right? That's the definition of being in the middle, is that I have the exact same lengths on both sides. So coming here, last thing, if I know this whole thing is 24, take a second and think. The whole thing is 24, what does that make these 2 pieces then, if J is the exact middle of 24? Well, that should be 12 and 12, right? 24 in half, right? The middle is the halfway point. So there's all my pieces all the way around the outside. Now let's look at the mid segments. That was just the outsides of my shapes. The mid segments, again, what we know is that the mid segment is half as long as the side it's parallel to. So I'm going to erase these colors here. For example, let's go ahead and answer this question. It says JH is parallel to, that's what the little symbol is, what? Well, here's JH. It is parallel to the side it doesn't touch. Hopefully we can see that. Take a second and think. What would JH be parallel to? JH is parallel to DF. Now we can kind of see that, right? We can kind of slide it over. Whoop, those are parallel. So because of that, JH is going to be half as long as this whole side. That's the new relationship we're finding out here. So the magic of what happens is this whole side would be what? We know that it's 8 and 8. Take a second and write down. What is that whole side then? That whole side is 16, right? 8 plus 8. So this side here is half as long as 16. Well, thinking this through again, if it's half as long as 16, what is half of 16? 8 as well. So this magic thing kind of happens here when we say that this whole side, compared to this one, This one is half, right? What ends up happening is we get lots of little halves all over the place, 8, 8, and 8. So looking here as well, I can do the same thing on this side. I know this whole side is 24, right? This whole side is 24. And this side is parallel to, take a second to think, GH, right? Those are parallel. They go the same direction. So we want to think this whole side is 24, and the small side is half of that. So what is that? 12. Again, we see 12, 12, and 12, 8, 8, and 8. So take a quick guess here, what you think this last side is going to be based on what we have here. 10.6, right? It's half of this whole side, the whole thing, and these are the two halves, so it's also going to equal that as well. So there is all of that. They only asked for EF, which we can find very quickly, actually, by doing a little bit of math here. EF is this whole thing. That's going to be 10.6 plus 10.6, right? That's going to give us that whole length. So 21.2, I believe. Might need to do that in the calculator. We won't answer this question just yet. We'll come back to that one later. So that is the concept. You might be a little bit confused if you didn't watch the Edpuzzle, but that's what we talked about in it, right? My big side compared to that little mid segment, we have that half double, right, relationship going on. So I want you guys to try this one now. We are on example 9. Take a second to get to example 9. Yeah. Okay. So now that we're on example 9, yeah, let's go ahead and again, before we answer the questions, they are telling us these are the mid segments. What I want you to do then is find the lengths of each big side to my triangle here. I'm going to give you one hint. I'll do one with you, and then I want you to try the other two. Now, again, the relationship we know is that the mid segments are half of the sides they are parallel to. So I've got this side. Which mid segment is parallel to it? The 6, the 5, or the 7? The 6 is. So what that tells me is this big side is going to be double that. What would that be? 12, right? 6 times 2. So 6 times 2, that gives me the whole side. Go ahead and find the lengths of the other two big sides based on that same fact. What would those be? Well, this is parallel to the 7. So this whole side is double that, 14. And this is parallel to the 5. So double that, this whole side is 10. Now, one of the questions they will ask is to find the perimeter. We haven't talked about perimeter too much. It's a word you should know. You should know that from earlier in your schooling, right? Perimeter means add all the sides together. So we want the perimeter of x, y, z. Do you see the triangle x, y, z, the whole big triangle? We need the sides of those added together. So what are my 3 sides of that big triangle x, y, z? Well, we've got 10, 12, and 14, right? That's our whole big triangle, yeah? So we're just going to add those together, and we would call this the perimeter. This would be how far you would have to walk if you wanted to walk all the way around the triangle, right? So that's 36. Correct me if I'm wrong. That would be the perimeter, all the way around the outside. So if they ask you for the perimeter, you have to know all the sides to the shape they're asking you about. So one question on the homework will be like that, where you have the numbers, you just got to find all the sides of the triangle they want, and then add them all together. So once again, I'm skipping around. Stay on your toes. We are on example 5. Take a second to get example 5. Okay, so the other questions you will have in the homework will again be solving equations as usual. So we have to correctly apply the relationship here to write the correct equation. It is not true that this piece equals this piece exactly, right? That is not the relationship we talked about. What we talked about is this is half of this one, right? And again, that should make sense. The 34 is way too big. There's no way for the 3x plus minus 1 to be equal to it. Again, what we have is this half relationship. So I'm going to write this kind of as a sentence. I have 3x minus 1 is half of 34. That's what we know. This is the relationship we know. So we can translate this into an equation. I'm just going to go kind of piece by piece here. I've got 3x minus 1. When I say something is something else, what I mean is, in math terms, those things are equal, right? If something is something else, those are equal. And then we have half of 34. So take a second to find that. What is half of 34? Well, let's see. 34 divided by 2, right? This is going to be 17? Yeah, that should be right. Yeah. So this is now a true statement. 3x minus 1 is half of 34, and half of 34 is 17. So these are equal, right? So take a second to solve that, and then we'll try it again with the next problem. So adding 1 here, this works out pretty quick and easy. 3x equals 18. I'm running out of space. Ugh. You should have gotten that x equals 6. And again, be careful you're applying the correct relationship. We're going to try it again on the next one. Same thing. It's not that this equals that. It's that the small one is half of the big one. Let's look at the next one. Okay, so we're going to try the same thing here. We're going to say the small one is half of the big one. So write that as a sentence just like I did. I said 3x minus 1 is half of 34. I need to say this one is half of that one. Write that as a sentence. 6 is half of x minus 1. This is going to be a little bit different and a little weird. Let's write this as an equation. So I've got 6. And then I've got is. What did we say is was again? That's equals, right? And then I have half of x minus 1. Now, I'm going to write it this way. However, there's an easier way to kind of think this through. Half of x minus 1 means 1/2 times x minus 1. And I can't really take half of x minus 1 that easily. However, here's what I can do. If I know that 6 is half of x minus 1, what that means is the flip side. X minus 1 is double 6, right? If 6 is half of x minus 1, then x minus 1 is twice as big as 6. So I can write this equation this way, or I can think a little harder and go, okay, I know 6 is the smaller one here, right? So if I were to double 6, I could then set that equal to x minus 1. So I can do this instead. I can say 2 times 6 equals x minus 1. These are the same equations. You would actually get the same answers. So let's go ahead and solve this equation. It's a lot easier to solve here. The half kind of throws us off. A lot of you guys wouldn't be very good with solving that one. So try and solve this equation then. Okay, well, this is 12 equals x minus 1. I'm going to add the 1 over. And I get x equals 13. And then we're done. So be very careful, guys, in the assignment. If we have the smaller piece, we need to double it to get to the bigger one. Yeah. So dang it. Taught this poorly. Do I have time? Never mind. Let me go back and reteach this. Okay, guys, careful. We are on example 5 now, so take a second to get to example 5. So now we have equations. As always, we have to apply the correct situation here. Now, again, it's not that these are equal, right? It's that this one is half of the other. Now, how we're going to do this, though, what that means is if 3x minus 1 is half of 34, right? What that means is if I were to multiply this times 2, right, 3x minus 1 times 2, that would be 34. If 3x minus 1 is half, I should just double it, and then I get the whole, right? So here's how we're going to write this. It's going to be kind of weird. I'm going to multiply all of this by 2. When we say all of this, that means parentheses, right? So I'm going to do 2 parentheses 3x minus 1 equals 34. And again, that's because they're not equal, right? I need to double that small piece to give me the whole piece. So take a second to solve that equation, and then we're going to try it again. Again, when you're writing these equations, think I need to double my small one to get my big. Well, this is going to give me 6x minus 2, right? Distribute. Got to get rid of those parentheses. We're going to add 2. We get 6x equals 36. And then divide by 6. You should have gotten that x equals 6. And again, we don't need to plug in, right? We can just leave that be. So once more, with this picture, think double the small one to get the big. So again, keeping you on your toes, we're here at example 8. We're here at example 8. Make sure you're on the right slide. So think double the small equal to the big. So take a second to write your equation for this. Which one is your small? We're going to double that one. Equal to the big. Yeah, and then we'll check and see if the equation is correct. Well, this is my smaller side, right? And this is my big side. So I'm going to double 6 here. So that just means 2 times 6, right? Equals my big side, x minus 1. Check and make sure you did that properly, that you doubled the small one. You didn't double the big one, right? We want double the small. And solving this really quickly actually is pretty simple. That's 12, right? Add 1. We get x equals 13. So from here, you guys are going to go into the assignment, 4.3 assignment. You might need some extra help with it. I should be back near the end of class. After that, though, you also have the 4.4 Edpuzzle. Anything you don't finish, you guys know is homework over the weekend. We've got one more lesson left on Monday, so really make sure you're staying on top of this. If you've got any extra time, go back and do your old assignments.